Are you preparing for a GenAI interview? Then let's check if you are familiar with the core fundamental concepts of GenAI. This is the part two of the foundational concepts of generative AI. And in part one, we have looked at all the core concepts like architecture, what is a large language model, why it exists, and what are the different types of language model exist. And then what are all the different training phases of a large language model and what different parameters are used as part of training and what we can use as part of inference. So all this we have covered in part one of this Generative AI Fundamentals video. And this is the part two of Generative AI Fundamentals. In this video, we are going to discuss about how does that model file get stored on the disk and what are all the different formats and why it exists and how it got generated and stuff like that. And then how do we deploy a model from that file? And then what are all the different runtimes available to provide an API inference for that model and some of the API standards available. So let's get into it. So when a model is trained using a different techniques, what we saw in the last video, so it generates the model weights and the biases. And finally, those values get stored in a file on the disk. So that is the format we are going to look at how it gets stored. So the first format is the PTH or PT format, which is generated generally by the PyTorch. PyTorch is a famous Python library used to build models. So when you use PyTorch to build a model, it generates and stores those trained weights in PT or PTH file. And then same way, ONNX is another runtime which is used to build models. When you use ONNX runtime to build a model, it generates the file in ONNX file format. And there is another PyTorch format, which is kind of a checkpoint, like intermediate storage point for the model, right? So this is also generated using PyTorch. And then Transformers library generally stores those weights and the biases in the bin format. There is another library which is very famous, which is called SafeTensors library. When you train a model using the SafeTensors library, as it stores the file as .safetensors. And then this is another important format, the Llama CPP. This format is called GGUF format, GPT Generated Unified File. This is a very popular format for running things on local. So this gets generated when you use Llama CPP to build or train the model. When you use XLLama v2 to train the model, it stores the model weights and bias as .exl2. Then the last one is auto AWQ. It generates the file as AWQ. So as you see here, there are a lot of models. There could be a few more formats available. At a high level, I covered the important file formats in the libraries. Now we got a big question, right? Why so many formats and which format is right for what reasons and what should I use when I wanted to build something? What should I use and what is the perfect fit for me, right? So that's why we need to understand the reason behind each and every type at a high level, right? So the Python based format is something like a legacy version of the model, and this is very early version and it has its own problem of pickle vulnerability. So this is used during the research and training phases of building a model, but this is definitely not a model format which we use for the production version or any of the production usage because it has a lot of vulnerabilities. If you want to use a model file in a production version, ONNX file format is the best file format for production version, and it provides a cross-platform deployment capability. So it is platform agnostic. You can deploy it on any platform and stuff like that. Okay. As I mentioned earlier, this is like whenever you are building a PyTorch based model, in between during the training phases, if you want an intermediate save checkpoint, you can save that checkpoint so that whatever training you have done, you don't lose it if the training got crashed or something like that. It's kind of an intermediate checkpoint for saving the models on the disk, and that is what this format is used for. And then this is a legacy format for Transformers library. It's kind of a deprecated version. The safe tensor is one of the key important file format. So it provides a high security standard, and it is the go forward standard for sharing the models and loading the models faster and stuff like that, right? It is the go forward model. This is one of the key format you can find a lot of times in the Hugging Face library. Next one is very important model, this GGUF. This is a, as I said, GPT Generated Unified File format. And this one is predominantly used for local deployments, like when you deploy a model on your local laptop. So this is a very compressed version of the model, so which is easy for us to run it on a CPU-based local desktops, right? So that is what this format is for. This is a very important model. So there are only three important models which we need to be aware, which is SafeTensors is best for sharing the model files and during all that, you know, prototyping and stuff like that. And then GGUF is best for running the models in local. And then the ONNX is best for cross-platform deployments. And then the next two models are also equally important. This is what production grade multi-tenant formats, right? So this is a high-end speed, right? Optimized for NVIDIA GPUs. And this is specific for NVIDIA GPUs. They created this model, and this runs on the NVIDIA GPU with super fast inferencing output, right? So this is a specific model. And the last one is server-side inferencing. This is also designed for high-performance cloud using vLLM as a serving engine, right? At a high level, if you look at it, ONNX, SafeTensors, and GGUF are pretty much for a local development, testing, prototyping, and stuff like that, right? And then the EXL2 and AWQ are kind of a production grade stuffs. Sometimes ONNX could be a production grade stuff. We can deploy ONNX as a production grade version as well. But definitely GGUF and Safe Sensors are for local deployment and local testing and stuff like that, sharing the model files and stuff like that. Now, let's look at the deployment options. So now we have seen how the model file is generated and what format it gets stored, and how do we deploy this file and what are all the options we have to deploy this file. So the first option is a managed cloud API option. This is predominantly what we use. So when we register and get APIs from OpenAI, Gemini, or Claude or anywhere, what we generally do is they deploy the model and they provide us an API key and we pay for them and then use the API key directly. So in this case, the main thing we need to understand is the infrastructure is managed by the provider. In this case, it is Gemini Pro 3. So the Google manages the infrastructure, and then they offer the proprietary models, because when I say proprietary models, this model weights are not shared. This is all proprietary to Google itself. They own that model. We pay using a pay per token model. When we use the APIs using a managed cloud option, we pay per tokens. And then this runs on the Google Cloud itself. And then lastly, it gets exposed as a public API URL. So we get to use a public API URL to access the completion endpoints and all the different endpoints which they provide. So this is the most common way of accessing inference APIs from the standard AI providers like Google, OpenAI, Microsoft, Azure, Claude, etc. The second option is very important. So we want to use Gemini Pro, but we want a little bit more controls on different aspects like security, data residency, and the quota limits, and the tuning, and the pipeline, and all that stuff. We don't want to use the public API URLs. And so in this case, still the infrastructure is managed by Google. We get access to the proprietary models and we pay per token basis. It runs on Google Cloud. Everything remains same except we get a private URL, and we get a private URL through a Vertex AI, which is their Google's AI platform. So from there, we get some more granular controls of security, the token limits, rate limits, and then data residency and stuff like that, right? The next option is using Google's infrastructure to deploy a custom model. So custom model means it is not proprietary, it is a kind of an open source model. Right? In this case also, the infrastructure is managed by Google, but we pay for the infrastructure and it runs on Google Vertex AI, and we get a private URL through Vertex AI. So this is for open source model. The difference between this and the previous one is the previous one is for proprietary models like Gemini Pro. This one is more for open source models like Llama. And then the next one is a self-hosted endpoint. In this self-hosted endpoint, there is nothing managed. We have to manage all the infrastructure. We buy GPUs and then we need to manage it in terms of scaling up and scaling down, all these things. How do we deploy the model? Everything. And in this case also, we deploy the open source models and then we pay for the infra, whatever the infrastructure we buy. Like if we buy a GPU, then we pay for per hour GPU rate. And the example platforms for doing that is like Runpod or Hugging Face and places like that. In this case, also, we get a private URL, which is kind of OpenAI compatible, or it could be like a general API, HTTP REST API also. So the next option is serverless. Okay. So serverless is something similar to self-hosting option, but here the only difference is the infrastructure is managed by the vendor. In our self-hosting option, we manage the infrastructure. Since it is serverless, the infrastructure scaling up, down, all these things are managed by the vendor. And then it again here also we can host the open source models, and then the payment method is slightly different from self-hosted option. In self-hosted option, the payment method is going to be like a static payment method. Here, it is like so dynamic. Since it is serverless, it could be pay per token or pay per GB of usage or something like that. Okay, so that is the another difference. So here the things runs on either Azure Cloud or AWS SageMaker. All these things, Azure Foundry, AI Foundry is one of the serverless offering of deploying models. Same way, Azure SageMaker is another option for serverless options. So in this case also, we get a private REST endpoint and then we use it for our inferencing. The last option is very important and everybody's favorite option, which is local deployment. In this case, it is totally managed by you because you deploy these models on your local laptop, and you can deploy only open source models, of course, and it is totally free. Since it is your infrastructure, you deploy it, it is totally free, nothing to pay, and it runs on your laptop and you get private REST or OpenAI API endpoints, right? These are all the possible options to deploy a model. Next is runtime. Okay. So if you think about runtime, there are so many runtimes available. And first question naturally which comes to our mind is why there are so many runtimes available. So primary reason for having multiple runtimes is like it started with supporting of our single GPU, and then there is a multi GPU requirement came in. So then there is a hardware specific requirements like NVIDIA or AMD chip optimized runtimes, and then edge device support, and then OpenAPI compatibility. There are a lot of reasons why these runtimes keep getting evolving. So there are many runtimes available, but we are going to look at a broader level, three main categories of runtimes, which is very important for everyone to understand. So the first category is the Llama CPP. So this one is considered as a kind of a development or like local deployment version of it. So this one can run on CPU, GPU, and Apple devices and stuff like that. Okay. So primarily meant for development testing and local deployment and stuff like that, right? There are a lot of frameworks built using Llama CPP as a backbone, right? So some of the famous frameworks are Ollama, LM Studio, Jan, are some of the frameworks which uses behind the screen Llama CPP as a backbone. So the file format supported by Llama CPP is GGUF, right? GPT Generated Unified File Format. So this is one of the main thing when it comes to development, testing, and local deployment. Llama CPP is one of the main runtime which predominantly get used. Okay, in terms of high-end production serving, right? The multi-tenanted, high throughput, and batch serving and stuff like that. The vLLM is another very important runtime which is used for production kind of a setup. So this supports only specific type of file formats like the Hugging Face transformers file format, SafeTensors, AWQ, CPTQ, or different file formats which are supported by vLLM to serve a production grade multi-tenant batch model. And then the next one is Hugging Face text generation inference. runtime. Okay, so this is very specific to Hugging Face, and then this also supports Hugging Face, SafeTensors, AWQs, and GPTQ types. So this is primarily tightly coupled with the transformer models, and this one is predominantly optimized for CUDA kernels. And then this is focused on scalable API serving for Hugging Face models primarily, right? So that is this runtime. And the last runtime is TensorRT LLM. So this is a kind of a very, very custom built runtime for NVIDIA. This one requires a special file format like TensorRT. The TensorRT is a file format which gets compiled from either a PyTorch format or a ONNX format. So this is very much optimized for a high-end NVIDIA based GPUs, right? So these are all the different runtimes for production grade or development grade setup. The next one is API standard. So now we talked about all these models, deployment, inferencing and all. So is there any standards available to expose inference API? OpenAI has come up with a kind of a standard called OpenAI standard, which is for sending messages in a JSON format for the HTTP request, right? So the reason why they have come up with this standard is to standardize the LLM interaction and to grow the adoption of their APIs, and also to make it consistent communication between the client and the model. So what happened was it emerged organically, and then all the SDKs and all the other platforms across different providers started using that as a standard. In fact, vLLM, a famous runtime which we talked about in the previous section, also natively supports this OpenAI standard. But the real question is, do we need to enforce this standard? Is this standard enforced on all the LLM providers or the vendors? The answer is no. There are a lot of exceptions, like Google, Hugging Face. They followed a standard open API specification. So the main thing is we need to understand the key differentiating factor between these two things, right? These are two distinct things. A lot of times the words get kind of confusing, right? OpenAI is a standard which is kind of a runtime protocol for an LLM inferencing, which is created by OpenAI, and a lot of people organically started following it as a standard to make it easy. OpenAPI, on the other hand, is a specification formed by Linux Foundation long time back. So this is a descriptive spec for any API structure. So Hugging Face and Google are following the OpenAPI specification, but OpenAI is following OpenAI standards, and a lot of other providers also optionally support OpenAI standards for to make it easy. So this is the API standards. With this, we have come to an end of all the generative AI core concepts. I hope this is helpful for you. Please subscribe to our channel for more generative AI videos. We'll see you in next video. Until then, see you. Bye. Take care.